നമ്മുടെ സെക്കൻഡ് സെമസ്റ്റർ നമ്മൾ ആരംഭിക്കുകയാണ്. ഫസ്റ്റ് സെമസ്റ്റർ നമ്മൾ എല്ലാവരും നന്നായിട്ട് പഠിച്ചിട്ടുണ്ടാവുമെന്ന് വിചാരിക്കുന്നു. ഒരു മൗന പ്രാർത്ഥനയോടുകൂടി ആരംഭിക്കാം. Okay, so in our discussion we define probability. Okay, so how can we define probability, or where to we define probability? What are the situations in which probability assessment occurs? So that are very fundamental questions. Suppose this, let me give some examples. Suppose you are conducting a physics experiment. The physics experiment you will have, or you may have 1 unit of hydrogen is combined with 1 unit of oxygen. 2 unit of hydrogen combined with 1 unit of oxygen. Then you will get, what is the result? 2H2O. Okay, so if you conduct this experiment at any time, or anywhere, it may be conducted at USA, it may be conducted at India, it may be conducted at Germany, etc. So anywhere. And if you conduct this type of experiment under similar conditions, then the result is same. Okay, the result is same. So this type of experiments are called deterministic. Can be repeated under similar conditions. What is the speciality? Unique outcome. Okay, specialty is unique outcome. Now we consider tossing a coin. So what are the outcomes? Either head or tail. This experiment also can be repeated, but the outcome is not unique. That means 2 or more outcomes. 2 or more here we have 2 outcomes. Another diatossing. What are the possible outcomes? These are the possible outcomes. observe lifetime of outcome, any number in between 0 and infinity. Okay. So that is multiple outcomes occurs. So what are the speciality? This type of experience are called a random experience. Moreover, so what are the specialties? Random experience are experience, and then it's the possible outcomes are the possible outcomes known in advance. That means you know the possible outcome of coin tossing experiment is h comma t. You know the possible outcome of die tossing experiment is 1 2 3 4 5 6. You know the possible outcome of lifetime of light bulb, that is 0 to infinity. Possible outcomes are known in advance. Second is we don't know. We do not know which outcome happens for a particular trial. If we toss a coin, we don't know whether this is head or tail. After experiment you can see this is head or tail. So the possible outcomes are known in advance, but we don't know which outcome happens to a particular trial. So such type of experiences are called random experience. Yeah, the specialty is mentioned here. It should be repeatable under uniform conditions. It should have several possible outcomes. One should not predict the outcome of a particular trial. So this type of an experiment, this type of experiments are called random experiment. Okay. Random experiment. ഇത് രണ്ടും ഞാൻ നിങ്ങൾക്ക് ഷെയർ ചെയ്യാം. You can use these materials. The definitions are given. In a deterministic experiment, if you repeat the experiment, outcomes will not change provided the initial conditions of the experiment remain same. Experience അതുപോലെ തന്നെ random experience result or outcome may not be same if you repeat the experiment in a similar condition. So you can use these definitions in your studies. Now we consider associated with each random experiment there are some definitions. First one is sample space. What is sample space? Set of all possible are called sample space, and usually it is denoted as S or omega. Let us denote it as S. Sample space. ചിലപ്പോൾ omega ഒക്കെ ഉപയോഗിക്കാറുണ്ട് പല ബുക്കുകളിൽ. So what is the sample space of tossing a coin? That is h comma t. These are set of all possible outcomes. We consider another experiment, tossing two coins simultaneously. Tossing 2 coins. Next one is tossing 2 coins simultaneously. So the possible outcomes are HH, TH, HT, TT. Okay, that means tossing 2 coins. Similarly, tossing 3 coins. What are the possible outcomes? These are the possible outcomes. So similarly, you can consider this one is 3. Next is die. Possible outcomes are okay. Tossing 2 dice. 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, then 2 1, 2 1, 2 2, etc. അവസാനം 6 6. These are actually called ഇനി നമ്മുടെ ലൈറ്റ് ബൾബ് അല്ലേ, ലൈഫ് ടൈം ഓഫ് ലൈറ്റ് ബൾബ്. യെസ് 6. Some example of sample space. Here, set of all possible outcomes of a random experience called a sample space. Now, what are sample points? So, this every elements in this set. This is a sample point. This is another sample point. So, every individual element in a sample space is known as sample element, sample points. Now we consider event. Event is nothing but event is a subset of a sample space. Technically speaking, it is a subset of a sample space. For example, E1. This is an event. This is a subset of sample space. Another event is V2. Let's substitute that. And then HT or TH comma HT. So you can name this event as then at least exactly one head. This is the name of this event, exactly one head. That means th. This is a subset of sample space. In this case, we can write another 1 2 comma 1 2 comma 2 1. So the name of this event is sum of base value. So corresponding to that statement, the members are 1 2 and 2 3. So that are called event. That are actually subset of sample space. Okay, that is called events. There are three type of events: simple event or compound event. For example, this is a simple event. There is only one single element in that event, then but if the number of elements are more than one element belongs to that event, then we can say that is compound event. This is a compound event. This is a compound event. Because there are two elements of the sample space corresponding to this event or belong to that event. So this is an example of compound event. Now another type of event is mutually exclusive events. Mutually exclusive events. For example, if we take this, consider this, you can take this. Suppose E2 is equal to h comma t, and some E3 നമ്മൾ ഓൾറെഡി എഴുതിയിട്ടുണ്ടാവും. ഈ ഒരു 5 E5 equal to but that E2 and E5 are events, and the speciality of these events are they are not having any common elements. That means E2 intersection E5 equal to null set. E2 intersection E5 common element between E2 and E5. So this type of events are called mutually exclusive. Okay. Now the third type is mutually exhaustive. The definitions are given. You can read this also. So this is mutually exclusive. So mutually exclusive. E2 and E5 are now you consider another example. E2 is same as this one, E6, E6 HH comma TT. Learner. The definition is either both the heads or in a statement. Note that clearly E2 and E6 are disjoint because there is no any common element between E2 and E6. That means E2 intersection E6 such. At the same time, what is the speciality? If we take the union of E2 and E6, then that is S2. Okay. So if we take union, you will get the sample space S2. That type of events are called mutually exhaustive. E2 and I'll draw a then you can divide this sample space into different subsets. And the first subset is named as A1, this is A2, etc. AN. Okay, clearly this A1, A2, etc. ANs are disjoint. At the same time, combine this A1, A2, etc. AN, you will get the S sample space. So this type of collection of sets are called, or events are called, mutually exhaustive. Okay. So I think that is clear for you, mutually exclusive and mutually exhaustive. Now we consider equally likely events. If the chance of occurrence of an event is equal, then such events are called equally likely. Suppose you are tossing a unbiased coin, then E1 is equal to heads and E2 equal to tail. Unbiased. Biased means there is no bias towards head or towards tail. Unbiased. So in that case, this event E1 and E2 are same chance of occurrence. In unbiased coin toss, then you may get head or tail, equal chance. So if the occurrence of events are having same chance, then such events are called equally likely events. Now another is favorable event. Favorable event means if you give a statement like in this example, you are considering an event at least What are the possible outcomes? HH, TH, HT. So these are the possible outcomes. So at least one event, one hedge occurs. So this type of events are called favorable events. Okay, that is the collection of all sample points favorable to this statement. So that type of events are called favorable events. Now, problem. What is the statistician? Problem statistician begin with this random experimentation, because you don't know what are the outcomes coming for a particular outcome, but you know in advance what are the possible outcomes. You don't know what is the exact outcome of the particular trial. Okay, so there the role of statistician appears. Then what is the role? We have to predict, we have to give a chance for occurrence of hedge or for occurrence of tail. നമുക്കൊരു ചാൻസ് പറയാലോ, കൃത്യമായിട്ട് നമുക്ക് പറയാൻ പറ്റില്ലെങ്കിൽ തന്നെ we can say some chance. നിങ്ങൾ മഴക്കാലമാകുമ്പോൾ മഴക്കാലത്ത് നമ്മൾ കുട എടുക്കാറുണ്ട്. കുട എടുക്കണോ മഴ പെയ്യോ ചാൻസ് ഉണ്ടെങ്കിലല്ലേ നമ്മൾ കുട എടുക്കുള്ളൂ, ആക്ഷൻ എടുക്കുള്ളൂ. സോ വി ഷുഡ് നോ ദ ചാൻസ് ഓഫ് പോസിബിൾ ഔട്ട്കംസ്. ഒരു ഔട്ട്കം ഉണ്ടായിരുന്നുള്ളെങ്കിൽ നമ്മൾ പിന്നെ ചാൻസിനെ കുറിച്ച് ചിന്തിക്കേണ്ട, അത് തന്നെ സംഭവിക്കുള്ളൂ. ഒന്നിൽ കൂടുതൽ ഔട്ട്കം വരുമ്പോൾ ഏതിനാണ് കൂടുതൽ ചാൻസ്, അല്ലെങ്കിൽ ഓരോന്നിനുള്ള ചാൻസ് എന്താണ് എന്നൊക്കെ നമ്മൾ ആക്ഷൻ എടുക്കാൻ പറ്റും. അപ്പോൾ മഴ പെയ്യാൻ ചാൻസ് ഉണ്ടെങ്കിൽ നമ്മൾ എന്ത് ചെയ്യും? കുട എടുക്കും അല്ലേ? അപ്പം നമ്മൾ ആക്ഷൻ എടുക്കുന്നത് ബേസ്ഡ് ഓൺ ദ ചാൻസ് ആണ്. സോ ഹൗ ടു കമ്പ്യൂട്ട് ചാൻസ്? ഓക്കെ, how to compute chance. So the question before the statistician is how to compute chance of an outcome. That is a question for a statistician. So how can we compute chances? That chances are usually called probabilities. Okay, so there are several possible probability definitions available. Chance definition, or assignment of chance to certain events. Suppose let me consider one example, that is tossing a coin, tossing a single coin. So we are considering an example, that is tossing a coin once. So we consider two events, E1 and E2. We are not considering whether this is it is unbiased or not. We are just considering tossing a coin tossing experiment only. Okay, so we are not bothered about the so the in the example of rain today or rain or not, the weather condition. So you can predict the weather condition based on the previous experience. If the chance of raining today is more than 0.75, we can put an action, that is we can take umbrella in our back. If the chance of raining today is less than some 0.1, it's very close to 0, then we don't want to take this umbrella in our back. നമ്മളൊക്കെ ചെയ്യുന്നുണ്ട്, ഇതെല്ലാവരും ചെയ്യുന്നൊരു കാര്യമാണ്. മഴക്കാലമായ നമ്മൾ കുട എടുക്കും, വേനൽക്കാലമായി എടുക്കില്ല. കാരണം നമുക്കറിയാം നമ്മുടെ ഉള്ളിലൊരു പതിഞ്ഞ് കിടപ്പുണ്ട്, മഴ പെയ്യാൻ ചാൻസ് ഇല്ല. നമ്മൾ പറയുന്നത് അത് തന്നെയാണ്, ചാൻസ് ഇല്ല, ചാൻസ് ഇല്ല, ചാൻസ് ഇല്ല. അതിനനുസരിച്ചാണ് നമ്മൾ ആക്ഷൻ എടുക്കുന്നത്. സോ ഓട്ടോമാറ്റിക്കലി വി ആർ യൂസിങ് പ്രോബബിലിറ്റി തിയറി ഇൻ അവർ ഡെയിലി ലൈഫ്. നമ്മുടെ ഡെയിലി ലൈഫിൽ പ്രോബബിലിറ്റി തിയറി വെച്ചിട്ടാണ് ആക്ഷൻ എടുക്കുന്നത്. നിങ്ങൾ ആലോചിച്ച് നോക്കിയോളൂ. ഇന്ന് എന്താണ്, ഇന്ന് നിങ്ങൾ ഉച്ചയ്ക്ക് ഭക്ഷണം എടുക്കുന്നു കോളേജിൽ വരുമ്പോൾ. വാട്ട് ഈസ് ദ റീസൺ? വിശക്കാൻ സാധ്യതയുണ്ട്, അതാണ് അതിൻ്റെ റീസൺ അല്ലേ? യു ആർ അപ്ലൈയിങ് പ്രോബബിലിറ്റി തിയറി. ഓക്കെ, ഇൻ എവരി യുവർ ആക്ഷൻ യു ആർ അപ്ലൈയിങ് പ്രോബബിലിറ്റി തിയറി, സ്റ്റാറ്റിസ്റ്റിക്സ്. അത് കാൽക്കുലേറ്റ് ചെയ്ത് നോക്കിയിട്ടൊന്നുമല്ല. എനിവേ, based on the experience you are applying the probability theory. Okay, so the probability theory is very important in our daily life, in every reports, in every statistical studies. So we can define probability like probability of E1. So you have to conduct an experiment first. You may, to assign the probability to this event, you may conduct toss coin 10 times and observe number of suppose this number is smaller and this is small n, then we use this value m by n. So that is probability. There is an assignment. So if you obtain a pattern like this, H H T H T H T T H H. So if you obtain this pattern, so what will the probability of heads? Total head will be number of heads divided by total number. 1 2 3 4 5 6 6 by 10. So this number is assigned as the probability for obtaining head. So probability of obtaining head tail will be 4 by 10. Only 4 T's are observed. Okay, so that is the idea of method of assigning m by n. M is the number of all possible number of favorable cases, and n is the total number of cases. Okay, number of favorable cases divided by number of total cases. The number of heads divided by total number of outcomes. So this definition is called classical definition. So this is classical definition. Classical definition. What are the speciality of this classical definition? You know that 0 is the number of heads can be 0. Or number of heads can be any number in between so the possible values of m is 0 to n. So what will be the possible value of, you can divide this by n. So the possible values of probabilities are 0 and 1 using this classical definition. Okay. So that is note that for an impossible win, that is null set. Null set is an impossible win. That probability in null set you don't have any sample point in the null set. What is actually null set? Null set is equal to empty set. Okay, there is no element, so the value will be, the probability of 5 will be 0 by n. That is 0 by n means 0. We consider sure event. Possible outcomes. So P of S equal to, what will be P of S? If there are n number of possible outcomes, then divided by total n. And for all other cases, that means we consider an event A, then 0 is the extreme null set, probability of null set, that less than or equal to one is the probability corresponding to, yes. So these are the concepts. Now, what are the limitations? So this is a classical definition. What are the limitations of this classical definition? You know, this, if n tends to infinity, n becomes infinity, then automatically this term m by n term will go to 0. If n tends to infinity, the m by n term go to 0. That will make some problem in our definition. always we get infinity. ഇപ്പോൾ നമ്മൾ ഇൻഫിനിറ്റി നമ്പറുള്ള ഒരു എക്സ്പെരിമെൻ്റ് ആണ് കൺസിഡർ ചെയ്യുന്നതെങ്കിൽ ഏത് ഇവൻറ്റിൻ്റെ പ്രോബബിലിറ്റി എടുത്താലും 0 വരും, കാരണം താഴെ ഇൻഫിനിറ്റി ആണല്ലോ കിടക്കുക. If you are deviating from games of chances, like tossing a coin, throwing a die, etc., the definition cannot be. അപ്പോൾ നമുക്ക് ഈ നമ്പർ ഓഫ് ഫേവറബിൾ കേസ് നമ്പറൊക്കെ വരണമെങ്കിൽ അങ്ങനത്തെ എക്സ്പെരിമെൻറ്റിനെ പറ്റുള്ളൂ. ടോസിങ് കോയിൻ, ഡൈ ടോസിങ് എന്നൊക്കെ പറഞ്ഞിട്ട്. അപ്പോൾ നമ്മളൊരു എന്താണ് ചോദ്യം എങ്ങനെയാണെന്ന് വിചാരിക്കട്ടെ. വാട്ട് ഈസ് ദ പ്രോബബിലിറ്റി ഓഫ് lifetime less than c? ഒരു ലൈറ്റ് ബൾബിൻ്റെ ലൈഫ് ടൈം ലെസ് ആൻഡ് സി ആണ് പ്രോബബിലിറ്റി എന്താണ്. അപ്പോൾ അത് ഇങ്ങനത്തെ ഈ ഡെഫിനിഷൻ, ഈ കൗണ്ടിങ് ഡെഫിനിഷൻ വെച്ചിട്ടൊന്നും കണ്ടുപിടിക്കാൻ പറ്റില്ല. ദാറ്റ് ഈസ് ദ ഡിഫിക്കൽട്ടി. Another limitation is that it does not contribute much to growth of the probability theory. അപ്പോൾ ഇതൊരു വളരെ സിമ്പിൾ ഡെഫിനിഷനാണ്, വളരെ സിമ്പിൾ, വളരെ ചെറിയ പക്ഷെ നമ്മൾ ഉപയോഗിക്കാറുണ്ട്, ഈ ഡെഫിനിഷൻ ഉപയോഗിക്കാറുണ്ട്, കൂടുതലായിട്ട് തന്നെ ഉപയോഗിക്കാറ്. എനിവേ ഒരു ഫൈനൈറ്റ് കേസിലൊക്കെ ഉപയോഗിക്കാൻ പറ്റുന്ന ഡെഫിനിഷൻ. അപ്പോൾ അതിനെ ഒന്ന് സ്ട്രെങ്തൻ ചെയ്യാൻ വേണ്ടിയിട്ടാണ് ഫ്രീക്വൻസി ഡെഫിനിഷൻ. സോ നെക്സ്റ്റ് ഈസ് frequency definition. Frequency definition. Frequency definition is nothing but, suppose you are tossing a coin ten times. Suppose you are observing 5 heads. This is n, this is heads. Suppose this is 10. Suppose you continue this process, so you may get 9. If you double this, you may get 21. If you double this, or if you make close to 100, then maybe 49. And when you increase the number, it may go to so proceeding like this, you can see that fraction, that is 500 by 1000 or 4099 by I guess you may observe a pattern like this, so that this fraction, that is 499 by 10,000, that will be close to 4999 by is close to this fraction. This fraction converges to. That means m by n converges to or that is denoted as p. So that value is assigned as p. that value is assigned for the probability of hedge. So instead of stopping the experiment for a finite number, we continue the process, and we can see that this fraction converges to a number, and that number is taken as the probability of that event. Okay, so the frequency definition is probability of A is equal to limit n tends to infinity m by n. So this is the definition of the frequency definition of the probability. So we have studied two definitions, classical definition and frequency definition. Now, very interesting. So we have studied classical definition and frequency definition. But very important limitations of these two definitions are, one is, you might have studied several mathematical topics like calculus, real analysis, integration theory, etc. So there are several well-established mathematical topics, mathematical theories, calculus, real analysis, integration theory, etc. So these are tools. Okay. Problem is this one: how to compute probability. Tools are calculus, analysis, integration theory, etc. The problem before the statistician, in front of the statistician, is how to compute probability. Okay. So a statistician need to address using available tool. The first two possible definitions are introduced. So the first approach is classical definition. Second approach is frequency definition. But in classical definition and axiomatic definition, not using any mathematical tool. Limit and action, that's all. In frequency definition also we are using only limit conception. Other huge number of mathematical results, so we are not using that informations. Okay, so the question is, how can we use these tools, or how can we compute the probability using these tools? Or can we compute the probability using this mathematical probability using majority of mathematical tools. That is the question. So the answer is search resulted in axiomatic definition. Okay. So we shall study the axiomatic definition. What is the definition? Let S be the and F be the sigma field. Sigma field is actually, it is a collection of A if A is a member of script F, A complement if A comma B or A1 comma A2 comma etc. belongs to countable collection belongs to F, then countable collection എടുത്താൽ അതിൻ്റെ യൂണിയനും എവിടെ ഉണ്ടാവും? യൂണിയൻ equal to 1 to അങ്ങനെയുള്ള ഈ രണ്ട് പ്രോപ്പർട്ടി സാറ്റിസ്ഫൈ ചെയ്യുന്ന ഇവിടെ പറഞ്ഞിട്ടുണ്ട് സ്ക്രിപ്റ്റ് എഫ് ഈസ് എ നോൺ എംപ്റ്റി സെറ്റ്, ദ എലിമെന്റ്സ് ഓഫ് എഫ് ആർ സബ്സെറ്റ്സ് ഓഫ് എസ്, ഇഫ് എ ബിലോങ്സ് ടു എഫ് then A component belongs to F, if A1 A2 etc n belongs to F then A1 union A2 union etc belongs to F. അതാണ് ഞാനിപ്പോൾ എഴുതിയിരിക്കുന്നത്. ഓക്കെ, സോ ദാറ്റ് ഈസ് സിഗ്മ ഫീൽഡ്. സോ ഇത്രയും കാര്യങ്ങൾ സിഗ്മ ഫീൽഡിൻ്റെ ഭാഗമാണ്. We continue the definition. Let S be a sample space and let F be the sigma field. Then a real valued function. സെറ്റിൻ്റെ ഫംഗ്ഷനാണ്. റിയൽ വാല്യൂഡ് ആണ്. റിയൽ വാല്യൂഡ് സെറ്റ് ഫംഗ്ഷൻ ഡിഫൈൻഡ് ഓവർ satisfying P of അതിന് സബായിട്ട് 3 കണ്ടീഷൻസ്. ഒന്നാമത്തെ എന്താണ്? 0 less than or equal to P of A less than or equal to 1. Probability of sample space. Third property, probability of union equal to 1 to infinity AI equal to summation I equal to 1 to infinity Defns means AI intersection AJ equal to null set comma I not equal to J. Intersection AJ equal to null set or I not equal to J. So this is the S be a sample space and F be the sigma field. What is sigma field? Sigma field is like this. This is a collection of sets. In that collection, null set will be there, whole set will be there. This is null, this is yes, and if A is there, then A component will be also there. Then a2 etc. a infinity. Infinity, then its union its union will be also in this set. So this is F. So inside F you can have null set, whole set, A complement, A1, A2 etc. then A infinity, then union also there. That is the sigma field. You are defining a function from this sigma field to real value, sorry, real line. So we are defining a function p of a from the sigma field to real line. What are the speciality of this function? S equal to 1 and P of union A equal to summation B of A. So this is the definition of axiomatic definition. So if you define probability like this, you can exclude this one for the definition, because that is the definition of sigma field. Okay. Sigma field. This is a sigma field. So this is a definition of axiomatic definition of probability. Sigma field ചോദിക്കുമ്പോൾ sigma field എഴുതിയാൽ മതി. Axiomatic definition ചോദിക്കുമ്പോൾ അത് എഴുതുക. Benefit, we can compute probability using all mathematical tools. Okay, so that is advantage. Okay, now before going further with this theorems on probability, we must understand some idea of set theory, because we are using available mathematical theories. Set theory is one of the major mathematical theory. Okay, so you can, so what is set? What is set? What is set? defined objects. For example, the collection of all students studying in BSc Mathematics B batch second sem. So that is a set. Now collection of odd numbers in between 1 and 10. Collection of rivers in South India. Collection of metropolitan cities. That are all sets. Okay. Usually we represent collection of numbers, collection of letters. This is collection of numbers. So how can we represent a set? There are one is roster method, second one is rule method. Roster method, you have to put all the elements like this. You have to display. Here each and every element of the set is listed or mentioned. You can see the name of the students listed here for the attendance. So this is roster method. Collection of all students, name of all students I have displayed. So this is a roster method. What is rule method? For example, we can put some statement like this. Here a rule is stated by which all elements of the set intended to be identified. For example, set of all students having mark 50% above. So all the students, those who are having mark greater than 50% will be listed there automatically. Okay. Or set of all rational numbers. You need not to write all the rational numbers. That is countable. We cannot write in a book that is infinite number. So you can put some statement like that. Set of all rational numbers. Here we have an example. X is the vowel among English alphabets. So this is a rule method based on rule. And there are different type of sets. First one is finite set. A set which contains a finite or fixed number of elements is called a finite set. Here we have an example. A equal to 1, 2, 3, 6, 8, 10. So this finite number of data is available here. So this is finite set. And here we have another this is a composite number between 12 and 8. This is another set. And I think being a mathematics student, you might have studied all these operations. Another is infinite set. That is infinite number of data are available here. Natural number, x is a natural number, or x is an integer, y is an integer. Set of all integers, set of all natural numbers. They are all infinite sets. Singleton set, a set containing only one element, that is singleton set. A equal to singleton 0, b equal to singleton 4. Then null set. There is no element in that set. Then universal set, the whole set. Universal set. A universal set is a set of all elements which are taken into consideration in our discussion. Then subset, superset. If A is a subset of B, then all the elements in A will be an element of B. So that is the idea of subset. If A is a superset of B, then A will contain all the elements of B. That's the idea. Equal sets. If the elements in two sets are same but maybe displayed in different order, so such sets are called equal sets. That is A subset of B and B subset of B. Equivalent set. That is if there are equal number of observations. Number of observations are same. Not the observation, but the number of observations are same. Then we call it as, here A is equal to x, y, z and B is equal to 1, 2, 3. Then A and B are equivalent. Not equal, but equivalent. Power set. Power set is the set of all subsets. All subsets. Set of all subsets of a sample space or an experiment is called power set. The number of elements in this power set is called cardinality. Here 1, 2, 3, 4, 5, 6, 7, 8. Here the cardinality is 8. Okay. Now that are some set operations. Now we consider some Venn diagrams and Venn diagram and other set operations. Union of sets, union of two sets A and B. This is A, this is B. So what is A union B? This is A. So union of set is represented as x belongs to A union B means x belongs to A or x belongs to B. Either x may be in here or maybe here or maybe here. That is either in A or in B or in both. So that situation is appears in union. So x belongs to A union B means x belongs to A or x belongs to B. This is suppose A is equal to 385 and B is equal to 368. Then A union B equal to 3856. So then it union. Another intersection of sets. Intersection. Suppose this is A belongs to A and X belongs to B. If A equal to 5, B equal to 5, 7, 9, then common element is 5. That is intersection. Disjoint. Disjoint means if there are two sets, there is no common element. Here A and B are disjoint. Here 1, 2, B is equal to A, B, C. There is no common element. Difference A minus B. That is X belongs to A and X not belongs to B. X belongs to A minus B means X belongs to A, but X not belongs to B. That is X belongs to A. This is A minus B. One, 2, 3, 2, 3, 5. But 2 and 3 are removed. That is 0, 1. Complement of set. What is complement? Suppose this is the sample space and suppose this is A. Okay. So what is complement? This is complement. So this is yes, this is A complement. Okay. So that is X belongs to A complement means X not belongs to A but X belongs to S. Okay. അപ്പോൾ നമുക്ക് തൽക്കാലം അവിടെ വരെയുള്ളത് നമ്മൾ പഠിക്കുക. ആൽജിബ്ര സെറ്റ് അടുത്ത ദിവസം നമ്മൾ പഠിക്കും. ആൽജിബ്ര സെറ്റ് നെക്സ്റ്റ് അടുത്ത ക്ലാസ്സിൽ ഡിസ്കസ് ചെയ്യാം. അപ്പോൾ ഇന്ന് പറഞ്ഞതിൽ ഒരു കാര്യം കൂടി പറഞ്ഞോട്ടെ. We have discussed sigma field. So what is field? Sigma field when the field കൂടി പറഞ്ഞേക്കാം. What is field? Field is a collection of subset of sample species having two properties. ഇവിടെ എന്താണ്? Finite collection. AN finite collection ആണെങ്കിൽ ഇവിടെ finite union ആയിരിക്കും. Closed under finite union. ഇത് closed under complementation. സിഗ്മ ഫീൽഡോ കോംപ്ലിമെന്റേഷൻ ഉണ്ട്. ക്ലോസ്ഡ് അണ്ടർ ഫീൽഡ് സിഗ്മ ഫീൽഡ് തമ്മിലുള്ള വ്യത്യാസം.